be very brief explanation.
Oh my
And then I gotta
God.
come.
It's even funnier when you think about, oh, I could see that Walmart.
We don't have to include what you're going to be talking about in your topics in your summary.
Okay, so here we go. This is hyperbolas. So since I'm recording for William and he can't see my hands, I'm gonna draw. It's not a good thing, but okay. So remember, we're talking about a double cone. Pretend that is really good. Okay, so hyperbolas are, if we were to take our double cone and cut straight down, like this, down the middle. See, he can't see my hand. Straight down the middle of the double cone. So what ends up happening on your cross section is you end up getting that, essentially, because we've cut down like this on our. So that's where a hyperbola comes from. Hyperbolas have all the same parts, basically, as ellipses. It is almost as if you took the ellipse and flipped it out. So all the parts and pieces and vocabulary is very similar. So, except for the names of the axes. They don't call it a major and minor axis with a hyperbola. So with a hyperbola, they can also open horizontal or vertically. This, I'm going to do horizontal first. So this is a horizontal hyperbola. It's horizontal because we are concerned about what the arms are hugging. So imagine, these are the arms. Aren't they sweet? The arms are hugging the horizontal axis, so that's what makes this a horizontal hyperbola. The axis between the two things, this to here, this is the transverse axis. And these things are the vertices. So the equation for a hyperbola is x squared over a squared minus y squared over b squared equals 1. So just like the ellipse, it has to equal 1. So that's one of the things that we're going to make sure that we do. There are also the way that we draw these, and I know because of my labs you guys don't have to draw them, but the way that we draw these is usually by setting up a box and doing these diagonals, which are actually some asymptotes. So imagine that there are these asymptotes that go like this, that the hyperbola can't touch. These have an equation.
What are they called again?
They're asymptotes. And the equation for the asymptotes is y equals b over a x, and it's positive and negative because they have the same slope and everything. They just won't fall in one line of the lines of the asymptotes. So we have a focus point on these, just like we do. It's in here. Again, inside of the shape, just like the focal point of a circle is inside the shape, and the focal point of a parabola is inside the parabola, and the focal point of the ellipse is inside the ellipse. The focal points here are inside the arms also. Your focal point is found with the same, it is the same negative C0 or C0. All that stuff is pretty much the same. I'm trying to see if there's any other vocabulary that you need for this. I don't think so. All right, so the other piece that you need to know about the focal point, though, in this case is, so what was the formula for the focal point of an ellipse? C squared equals a squared minus b squared. Remember, that's how we find the c. C equals a squared minus b squared. This one is c squared equals a squared plus b squared. So don't get confused. Now, I think the way you remember is ellipses, the equation starts with a plus. So to find the focus, you have to have a minus. This, a hyperbola, starts with a minus. So to find the focus, you have to have a plus, so that you can remember that you're using this to find your C value. What? That's where it comes from. So remember yesterday when I drew the ellipse and it had the triangle? That's exactly where it comes from. So it's a whole lot easier to see it on an ellipse than it is on a hyperbola for sure. Okay, so let's do one real quick, and I think once we get into it, you'll see they're very, very similar to the other conic sections that we've already done. So that pen doesn't work. All right, so they give me y squared, not y squared, hello, x squared. X squared over 25 minus y squared over 49. We are going to, equals 1. We're going to sketch the hyperbola. And we're going to find our vertices.
How's this different from what we learned yesterday? What's different?
It's a different shape. See? Ellipse goes like this. Hyperbola goes like this. Other than that, not a lot.
Should we basically find all of the information in the same manner, just with different equations?
Yep.
And
Okay.
There's no.
So now the one major difference is with hyperbolas, the way that you tell whether it is horizontal or vertical is not the same. So yesterday when we were doing ellipses, how did we determine whether it was vertical or horizontal?
Usually by what's under the X or Y, which one's bigger.
Yeah,
Here and
whatever's bigger, right? If it's bigger under the X, it's horizontal. If it's bigger under the Y, it's vertical. That is not the case with hyperbolas. With hyperbolas, that all that's doing is telling us how far apart our hyperbola is. So that doesn't tell us vertical or horizontal. What tells you vertical or horizontal is which one of those values is positive. So in this case, this is negative. Our positive value is the horizontal value. So the one that's positive tells you which way this thing is going to
If
go.
they're both negative, it's vertical.
So a lot of times, if they're, the reason I say this is because different books and different people write it different ways. A lot of times people will just write it reversed and put the y in front. So it'll be y minus the x value. In that case, the y is positive. But I don't want you to be thrown off if you end up looking at one and it says negative x plus whatever. If that front value is negative, it's a hyperbola. And they just wrote it in the wrong order. Or in a different order. And every book is different. So I want you to be prepared that you might not see it the way they want to do it. But this one, so the positive value is my x value. So this is a horizontal hyperbola, which means it hugs the horizontal. So my little arms are going to be hugging the horizontal. So before we sketch it, we will sketch it real fast. We'll find the vertices and we'll sketch it. So that means my vertices are on the horizontal. It's starting at a center of 0, 0, because we don't have anything up here with x and y, just like yesterday. So I'm starting at center. I'll go ahead and write that. Center, 0, 0. So my A value, what's my A value? 5. So since that's the case, then my horizontal vertices are going to be negative 5, 0, and 5, 0. So I'm going to just sketch this. Okay, so that would be where my vertices are. They did not put this word in the book, but the other way that you go, those are technically called your co-vertices. So I don't know if my math labs will call them that because it's not in the book, so they probably don't, but that is what they're called. So my co-vertices would be on the up and down in this case with my B value. So what's your B value? 7. So they would be 0, negative 7, and 0, 7. Okay, so what those do for you, they don't draw you a hyperbola or anything. All those do for you is create this box. So I'm going to draw a box. Like that. I know y'all don't really have to graph these on the thing, but it'll help it make sense. The diagonals of this box are the asymptotes. I can get the equation for them in just a second, but these diagonals are the asymptotes of this hyperbola. All right, so the equations of my asymptotes positive or negative b over a, so 7 over 5x. So that's the equation. Pretend that's what the center. That's a terrible sketch. So those are the equations of these asymptotes. And then all you do is you draw the hyperbola. I know it's horizontal, so it goes right here. Getting as close to it as it can to the asymptotes, but never touching it or crossing it. Like that. Now the actual graph of the hyperbola is just the pink part. All that other stuff, we just did to get to it. Okay, so now, what is the domain of this graph? Negative infinity to negative 5. Now, infinity is never in a bracket, but the negative 5 is a bracket because it touches that place at negative 5. Big U in union with, the graph doesn't start over. Remember, the graph is just the pink part. The graph doesn't start over again until 5. And that should be a bracket. And it goes to infinity. So the only thing we haven't found is our focal point, our foci. So let's do that real quick.
We have to do range.
Oh, we should do range. What's the range? Yeah, negative infinity, positive infinity. We do have to do range. And now we need our focal point. So c squared equals a squared plus b squared. Remember, they're already squared under here, so I can just put them in like that. 25 plus 49. So c squared equals 74. So take the square root of both sides. C equals square root 74. Square root 74 does not break down. So we would just call our focal point, our two focal points. Now remember, where they have to be on the horizontal, so that means they're going to be negative square root 74, 0, and positive square root 74, 0. And they'll be over here somewhere. There's your foci. Are y'all sort of kind of okay?
Yep.
All right.
These are really nice. Yeah, the biology too.
Oh, you're back. Okay. All right, so let's say this was the assignment that's going to happen tomorrow where they're all mixed up. What do I know for sure that it's not? What can it not be?
A parabola.
It cannot be a parabola. Why can it not be a parabola?
You can't have y squared and x squared.
Very good. Because I got both x squared and y squared. That indicates it is not a parabola, which also indicates to me that it has to be equal to what?
1.
1. Because it's either a hyperbola or an ellipse. Obviously, we're talking about hyperbola, so it's a hyperbola, but it has subtraction, so it's a hyperbola. But in order to make it equal 1, what do I need to do?
Divide by 100.
Divide by 100. So I'm going to divide everything by 100 and simplify. I just did it. Of course, when I'm using a real pen, not erasable.
You don't have the eraser?
I do, but I just picked up a real one for that line. I hurt her over sometimes. Okay, so now I'm looking for where my positive values are, where my positive variable is, and which one's positive, x or y. Which makes this
Vertical.
vertical. This is going to be a vertical hyperbola. So we can sketch it, but it says to graph it, but let's find all our pieces and then we'll graph it. So let's find our a value. What's your a value?
2. Wait.
Will A's go under Y now, or no, it stays under?
No, it stays. It's
It
still be
stays with the
5,
X.
right?
Okay, so it actually stays with whatever the vertices, wherever the vertices are going to be, whatever your major, in this case, your transverse axis is. That's your a value. It stays with the important thing.
So it's going to be under.
So it's under y this
Yeah,
time.
okay.
So my a value is 2. But that's why I was telling you guys yesterday, it really doesn't matter whether you call it A or B. You
Because
call
they're
it
subtracted anyway.
Yeah, you just know where it goes. As long as you know where it goes with the y value, which is the vertical value. As long as you know that, who cares what letter it has on it? Which means, so let's find our vertices now. So where's the center point of this particular hyperbola?
0,
0,
0.
0. So I'm going to put center 0, 0. How do I know that it's at 0, 0?
Because there's no.
Right, because there's nothing up here with x and y. There would have to be something in parentheses with x and y to change it. We'll get one in a minute that has that, but this one doesn't. So, all right, which means my vertices 0, 2, and 0, negative 2.
What were those things you were calling semi-vertices? Or is that just like a minor?
Co-vertices.
Is that just like a minor? What is it?
Yes, yes. It would be on an ellipse. They would be on the minor axis.
Because
On-
in math, or what is it, math lab? They call it something different.
They call it endpoints.
They call it
Like minor endpoints.
oh, minor endpoints.
So that's what it is.
Yeah. Now, but what you have to be careful of with the whole, and maybe this is why we always call the vertices co-vertices. Why you have to be careful with the major minor thing, because on a hyperbola, it could be a vertical hyperbola, and the wider axis could be on the horizontal. Do you understand what I'm saying? Because which actually we're going to have this time. Because look, it's going to be much wider at the x's than it is at the y's, but this still opens up and down. So you can't call these major and minor,
Because they can be stretched wherever.
right, in the same way. So it's kind of that can be confusing. So well, I'm going to call them vertices and co-vertices. Vertices means if it's a vertices, that means the graph of the thing that I'm drawing actually passes through it. If it's not a vertices, then it doesn't have to pass through. Okay, so the other value, whether you call it B or L or D or whatever you want to call it. Ooh, we could put Greek letters, and then we wouldn't all be as confused, maybe. Okay, so that would be the ones that, in this case, are going to be on the horizontal, are going to be 5, 0, and negative 5, 0. So, yeah, let's do the equations of our asymptotes. Y equals positive or negative 5 over 2. X points. So c squared equals a squared plus b squared. They're already squared under here, so you just add them together. So c is square root 29. This is a vertical, so I add and subtract square root 29 to the y value, so it's going to be square root 29 and negative square root 29. I think that's all the pieces. All right, so let's just sketch it. Just pause. It actually said to sketch it. Did y'all have to graph any of the ellipses yesterday on my labs? No?
But we did have to like recognize.
You had to be able to look at one and see. That's probably, I think, the same way these will be. But all right, so we know we're starting at 0, 0. I know I have vertical vertices at 2 and negative 2. So I have a box. Oh, I should have graphed it. It's terrible. All right. And I just realized our no, I'm wrong. Look at your. Can you imagine? No, I'm just kidding. Look at your asymptotes, and look at the equation for your asymptotes. Come on now, you spent a whole year studying the slope of a line. What's wrong with those?
That was fun.
It's upside down.
It should be 2 over 5.
It should be 2 over 5.
Why?
Because they're not. Because what would a line with a slope of 5 over 2 look like? Up 5 over 2. So it'd be real steep. And ours are just up 2 over 5. So that it was backwards.
So we don't even. Are you talking about the lines that go?
No, it's because I didn't tell you that when we flip our nothing else changes except for the equation of this. Okay,
So do we even need to find our asymptotes?
I didn't actually give you all the.
In ours.
Yeah, I think it's going to ask you for them.
Okay, because you can just tell once you find your.
But
vertices.
remember, you aren't going to be drawing them.
Yeah.
So we can tell by looking at drawing it, but it's going to ask you for the equation of it. So this, I didn't ever go back and draw the vertical version and put all the pieces together. But the only thing that actually changes is for a vertical hyperbola, this one. The only equation that actually changes is it's y equals a over b. And the foci goes in the other place. So that technically changes, but you still find it with c squared equals a squared plus b squared. Okay, I think, let me look and see if that's all we're supposed to do. It actually, technically the instructions were for us to graph it. We found our foci. Oh, let's do domain and range.
Oh.
What's the domain?
Negative infinity to positive.
Negative infinity to positive infinity. All right, what's the range? Yep. Does anybody have any questions over how we find the range or domain? Yes.
We're just doing the domain of the asymptotes, right? Not the box.
No. We're actually, realistically, the graph is only the green stuff.
Yeah.
We're doing the graph of we're doing the domain and the range of the green stuff.
Asymptotes, but the
These, yeah.
The R.
That's what I meant.
The arms, the hyperbola. Yeah. Yes, ma'am. We are. Okay. Any other questions? That's all the pieces of that. Now let's do one that has a center point somewhere else, okay? All the equations are the same. You just have to add and subtract it from your center point. So, how do I know that it's not at 0, 0?
Because the number just these with the values.
Yeah. There's values inside the parentheses, so that tells me that I have a different center point. So go ahead, don't say anything out loud. Let everybody write down the center point. Let's make sure that we write it down correctly. Everybody write down where the center is. Center at -3, -2. Okay. Does this open up and down or left and right?
Up and down.
Yeah, this one's up and down. It's vertical because that's where my positive value is. So this one's vertical. All right, so let's find our vertices. So whether you want to call it A or B or whatever you want to call it, what is it and what am I adding it to? If I'm finding my vertices, the part that the graph actually goes through. It's 3. And you are going to add it and subtract it from -2 to get your vertices. So that would make one of my vertices -3, 1. And the other one is going to be -3, -5. All right. My co-vertices or whatever, I don't know what they'll call it on this thing because it's a hyperbola and not an ellipse, but whatever they want to call it, the not important endpoints or whatever they call it. I'm adding and subtracting 2 from the x value. So it'll be -1, -2. And -5.
Why are they positive right there? Like the center's negative.
I'm sorry, ask me again. I can't
Like
hear.
the center's -3, -2, but A and B is just +3, +3.
Okay, because remember, the center point came from inside the parentheses, and what happens when we take something out of the parentheses?
It changes.
Uh-huh. These were not inside parentheses.
Oh, you should.
Yeah, just take the square root. Oh, they happen to be they're the same numbers. Yeah, that's coincidence. Purely coincidence. All right, let's find our focal point. So, I guess we can do our asymptotes. Positive and negative, 3/2. X. Our focal point, so c squared equals a squared plus b squared. Okay, so when I go to find my focal points, I found my c value of square root 13. I'm adding and subtracting my square root 13 to which value? The y value of your center, -2. And because it's asking us for exact answers, and we're not giving decimal answers here, can you add a square root of 13 to a -2? No, so you just write it down, -3, and then -2 plus the square root of 13, and -2 minus the square root of 13. Those are your focal points.
So we can't graph that.
We couldn't, like these 2 points, no. I mean, you would have to get the decimal to graph it, and they're irrational numbers, so they're not nice decimals, so. But you can get kind of a rough idea of where they are. We know they're inside the arms of our vertical hyperbola. So, let's see. Okay, so question, without graphing it, can you give me the domain?
It's still going to be negative infinity.
Negative infinity to positive infinity. And what about the range?
Negative infinity to -5.
Good.
With bracket and then u, then 5 to positive infinity.
Okay, so in this case, remember, it is not at the center point, so it's not symmetrical. So you were right about the -5, but then where does the other vertices start? So So I have one at -5, and then there's a space. Starts at 1. So right here, the ones that I have in pink up here, those are my vertices. And so the places where they touch are the -5. Then there's the big space, and it starts again at 1. All right. Are y'all good with that? Sorta? Okay. Okay. So now, I don't know. 6. Just 6. And this is 4.
Do we need a lot of students for this one?
All right, got to write the equation in standard form. So, standard form of a hyperbola, what does it have to equal?
1.
Mhm.
I'm like so glad this is the unit before the final exam,
Yeah, it's
or else my brain.
It does, y'all don't forget though, while you're all saying that it does have the vector, the vector things on it.
that was this.
That was the, yeah.
Vector thing?
Yeah. That. I did that yesterday for maybe 4, 3. Yeah, don't forget.
Also,
I don't know
where
if
you have
we'll
to
do,
draw
like,
the square and
what?
stuff.
Do what?
Where you have to draw the finish the triangle. Or is that-
Yes, yeah.
Oh, I guess maybe I'll have to test this in that.
Okay, so we have to put this in standard form, which means we need it equal to 1. So yes, I do need to divide by 144. But before I do that, I have to notice that my x squared and my y squared have buddies. My x squared has an x buddy, my y squared has a y buddy, which means I need to put this in parentheses, which means I need to do what?
Complete the square.
Yeah, we gotta complete the square.
I've grown fond of complete this way. It's not that bad.
I know, it's not, that's how I feel too. Once you do it so much, you just get like used to it. Okay, so, but when we complete the square, remember we want to leave coefficient of 1. So we're going to factor out the 16 from the x family.
Oh, that's bad that I said that.
Let's see, so it'd be 6x.
Mm-hmm.
And then from the y family, I'm going to factor out -9.
Yeah.
When is the second?
Oh, it's positive. Yes, ma'am, thank you.
I forgot to leave the space.
That's okay, just make a new line. Oh, no, you were trying to say, you're trying to not use too many lines too. Sorry. All right. So we got to find our b values, which on the first one is -6. Half that, -3. Square that, which is +9. And when I go to add my +9 to the left, that means I also have to add it to the right. But it is not just +9, it is 16 times +9 that I'm going to add. Okay, we've got to do the same thing for our y family. So my y, the b value of my y's is 8. Half of that is +4. Square that, and I get 16. So I'm going to add 16 in here, but when I go to add it to the other side, it's not just 16.
16 times the negative.
Right, it's 16 times -9. So, or -9 times 16, either way.
So cancel.
Okay, so now we did all of that so that I could write this using that middle term there. It's going to be 16, and it'll be x minus 3 squared. then this piece will be that. And you got to add all this together, but like you guys said, 16 and 9 and negative 16 and 9, those cancel each other out and leave just 144 over there. We just did all that work and it still doesn't equal 1. Now what? Divide by 1. Or divide by 144, sorry. Yeah, actually, the only thing that this one asked for was for the center point and to tell whether or not it was vertical or horizontal. So what is your center point?
3 negative 3.
And is it vertical or horizontal?
Horizontal.
Horizontal.
Y'all good?
Yes.
Anybody have any questions over that one? No?
It actually makes a lot of sense. I'll do
Eccentricity, we have eccentricity of a hyperbola as well. And again, so on an ellipse, the eccentricity explains how round it is. And in this case, it kind of explains how like, I don't know how you say it, but like how maybe narrow the arms are or how wide out the arms are, whatever. Same idea. It's like an ellipse has been flipped on its outside.
Yeah, a stretch or
Yeah, kind of like whether it's a stretch or compression or whatever. Same idea. That's what your eccentricity explains, the number. So the formula for eccentricity is, hold on, I will write. I think I spelled that right. E equals C over A.
Oh, so it's the same formula.
It is. And same idea, the more, I don't know how to say that. We'll look at 3 different ones and y'all can tell me how you would say it. Okay, so let's say here's my okay.
Is that a 400?
It is. I'm sorry. I made it mixed in with my Y there. All right, so let's go ahead and find our A, B, and C value just because. What is your A? 3. And your B? And let's calculate our C. So C squared equals A squared plus B squared.
Wait, why is it not minus?
Remember? When is it minus?
When is C squared plus? But it was always minus.
No. Remember, so I told you when we first wrote this down on here,
Because it's flipped.
because this is minus, this one's plus. But if it's an ellipse, this is plus and this one's minus. So square root 13, so that's my C value. So to find my eccentricity, square root 13 over 3. Which, if we were to get that as a, because it won't mean anything if you get 1.2. So,
Miss Bohannon, let's say the square root 13 is on the bottom. Would we have to rationalize if it was on the bottom?
unfortunately, yes. Unless, I don't know what MyLabs is looking for. They may be looking for the decimal answer.
Some of them did, and then some of them.
And some of them ask for the exact answer. So, but if it's asking for an exact answer, it makes you rationalize, yeah. So really quick, I'll show you what like some examples of eccentricity. So this one, so here's an example of a hyperbola, like this. This one has like an approximate E of, pretend that those sides look the same.
I was like,
They're terrible. It's hard to, when you're looking at things from the side, it's hard to tell. Okay, so this one has like an eccentricity of like 1.1. This one has one more like E equals 2. And then this one would be more like E equals 3. Or so it's like the more like bent it is. Compact something.
Maximum, how stretched it is.
Is there a maximum E? Let me think about that for a second. Yes, there would have to be a maximum E because C comes from a hypotenuse. There would have to be.
it has to be curved somewhat, right?
Yeah.
Because at some point it would just.
It would end up being like it would end up being a line. And you have to consider you're cutting a cone. What would the maximum? I have to think about it for a second.
That'd be a really wide cone.
And then
Or that would be a really like.
reaches that maximum.
I got
if
one of
you
them.
go beyond that, will it start to curve the other way? And
Right
then-
over.
Like it would be a different shape. Yeah, because once we get like if you're cutting, so if you consider the way we're doing it, so you cut straight across and you get a circle. You cut a little bit at an angle, you get an ellipse. You cut a little bit more at an angle, you get a parabola. You cut a little bit more at a hyperbola. And then you start to go back the other way, so you start going backwards. So it'd be parabola, ellipse.
So does each
Why not?
shape have two different eccentricities? Or does it, no? So like,
It was like one of both.
you have that one,
One of the
and then you like
Yeah.
put it next, and then you start coming this way, like,
Would it be different?
would it be the same?
I think it would be the same. I think one cut this way and one cut this way would have the same eccentricity. Because they're going to be
The trunk can
hyperbola.
fit all three edges. The trunk can fit like a piece of the
I thought you were about to
Okay.
say something completely different. I was like, hold on, how the heck do you know that chance?
I was gonna say it can fit a decent amount of dead ball.
I thought you said it could fit through. I was like, hold
So-
on.
I'm averaging.
So
the
this
average person.
says,
My truck can't fit in.
I guess that makes sense because it's C over A. It doesn't have a maximum, but it has to be greater than 1. That makes sense. But. Okay. Last one. This time they're going to give us pieces, and we have to write the equation. This is it.
She's gonna show some whisper, whatever they call it, dumb thing.
If I do good on this and do bad on the vectors.
That's what I'm just saying.
Don't do that on the vectors.
I don't really
I don't have a choice on that.
Look, I told you I will give you a picture.
Oh,
I
yeah,
don't
okay.
get it.
I could make
I'm not going to give you a picture on all of them, but on the word problems, I'll make the picture for you. Because
I still want to watch it, but I can do good on the assignment without.
no, you.
I do believe I'm not good at that. I really need to like hit this review hard.
I just go blank some.
So there's a.
Okay, so first, is this vertical or horizontal, and how do you know that?
Horizontal because the x is changing.
Good. It's a horizontal because your two foci, the x's are changing, which means one's in one place and the other one is a little bit this way. They're on the horizontal axis, so that means it has to be a horizontal hyperbola. I don't have the center point. Can somebody tell me how I might be able to get the center point from some of this stuff?
Take one of the x's and subtract from each other.
you know what you mean.
Yes.
Okay, so explain. So
Add them,
okay, why?
Find the minute.
so you can find the gap in the middle.
Yeah. So we're looking for the exact middle. So we're all thinking the same thing. So it's okay. Like I totally get what you're saying,
Yes.
and you're exactly right.
The number
If you're looking for the formula, it's midpoint. You just find the midpoint.
Yes.
But if in your head you're visualizing a graph, okay, here's my foci, and you're like, okay, I gotta find the middle. That works too. Whatever gets you to the middle. I'm gonna do it with the midpoint formula if y'all are okay with that. So that means I'm gonna add -9 plus -3, and then divide by 2, because that's how you find the midpoint. And I'm gonna add. Well, I don't have to do that part because it's gonna be 5. So.
I saw it right down because I feel like it's gonna go as hard on.
Yeah.
Or you just see if there's a difference of 6 and you divide by 2. That's what I did at first.
I know, but I feel like they're gonna give us like crazy numbers.
Turn -3 to a positive, said F, or change its signs. No.
At first I was like, wait, why is the X changing and not the Y? I was like, oh, it's horizontal.
So now.
So now, let's see, what else do I know? I know,
Well, now we know the top.
Oh, I know
half of our
C.
fraction.
so if this is the center, and that's one of my foci, then what is my C value? C is 3.
And then we can find A.
The C value is the one where it's like the distance between a vertices and or the difference between a foci and a center.
And so once we found the center, then it was easy for, well, maybe not easy, but you can see that it's 3 away from each of the focal points. So that tells me that my C value is 3. All right, and now I know my eccentricity. Remember how you find it? C over A, right? So if E equals C over A, I can plug in the pieces I know and solve for what I don't know. So E is 2, and I just found C to be 3, and now I got to solve for A. All right, solving for A. What do I need to do?
Multiply by A,
Multiply both sides by A to get it off the bottom,
then divide by 2.
and then divide by 2. So A equals 3 halves. Awesome. And now that you know that, you can find B, because we can plug it into my focus equation, C squared equals A squared plus B squared, and solve for B. So C squared is 9, and A squared is 9/4. Now we're just solving for B. That's 9/1. So I'm going to make it into a fraction with the same denominator as the other thing. So it would be 36/4. All I just did was get a common denominator so that I could subtract.
I like having a calculator.
27/4. That's B squared. Take the square root of both sides. 4 is a perfect square, so I can go ahead and do that. Square root of 27, it breaks down, but you don't have to break it down. I'll tell you why in just a second. I'm going to leave it as square root 27 over 2 is B. All right, because the whole point of this was for us to make an equation. And to make an equation, we needed a center point, which we found, and you need your A and your B. So now I'm just going to plug it into my equation. We said it's horizontal, so my horizontal piece is positive. So it's going to be x plus 6 squared. We found our A value to be 3/2, but remember when it's under here, it's squared. So it's going to be 9/4. minus y minus 5 squared. And then my b value is going to be underneath, but remember it's squared. So what happens when you square square root 27? Just 27. So it's going to be 27 over 4 equals 1. Now,
I did not like that.
can't leave it like that because it's those are compound fractions, a fraction within a fraction. No good. Yeah, but it's super easy because they have the same, the little fractions, the fractions on bottom, have the same denominator. So I just need to clear that denominator, and you do that. How do you clear a denominator? Multiply. So we're just going to multiply by 4, and that makes it, so if I multiply the top and the bottom by 4, which when you do that, you're technically not doing anything, right? Because you're multiplying by 1. That leaves it as 4 x plus 6 squared over 9 minus 4 y minus 5 squared over 27 equals 1. And that's it.
Yay. Does anybody like how many problems there are?
It has those fractions, right? It doesn't.
All right.
They had ones like this on yesterday, and I got confused at first.
Oh, because the compound fractions?
Yes.
Did they really?
Yeah. Then they had ones where you had to rationalize as well.
Yeah, you always have to rationalize it. Yeah, just go. Yeah, y'all, tomorrow, there are 2 examples. So, we'll do 2. I'll do them just because it'll help you. We'll do them.
What are we doing Thursday?
Review, I don't know, review. Review for the test. Because I said we were going to take it Tuesday, right? Didn't I say that? Wait, hold on. Something is Thursday. Is something Thursday? Like on the calendar. Oh, let me turn this off real quick. I don't either.